Okay, let's take a look at the quiz 10.4 to 10.5 review worksheet. And remember, the quiz will be very similar to this worksheet. There are a couple other worksheets and a couple other videos, but this should be the primary focus. Okay, the first question asks you to find the area of a dodecagon with a radius of 16 centimeters. So there's a couple of different ways you can actually do this problem. If you have a dodecagon, the first thing you need to know or identify is that you have 12 sides. So n is equal to 12. You can use the formula the area is equal to 1/2 the apothem times the perimeter. Recognize that the perimeter is equal to the number of sides times the length of a side. If you're given the radius for your central angle, you know that the sides are both 16. This central angle measure is 30 degrees. If you want, you can draw in the apothem. If you're using this formula, area is equal to 1/2 the apothem times the perimeter. This is 16. The apothem bisects that central angle, meaning that this angle is now 15 degrees. You need the apothem and you need the length of a side. So to find the apothem, you would use sine of 15 is equal to x over 16. So 16 times sine of 15, sorry, this is to find the side length. You get 16 times sine of 15 is 4.1. So x is equal to 4.1. So the length of a side is equal to 8.2 because x is only half of that side length. Then to find the apothem, you'll use cosine of 15 is equal to a over 16. So 16 times cosine of 15 is equal to a. And you should get that the apothem is equal to 15.5. So using this formula to find the area, it's 1/2 the apothem, 15.5, times the perimeter. The perimeter is the number of sides, 12, times the length of a side, 8.2, which is 98.4. So the area for this dodecagon should be 762.6 centimeters squared. Okay, that's one method to do it. You can also use the idea that if you have a dodecagon, you have 12 sides, and therefore you have, because it's regular, you have 12 congruent triangles. So you can find the area of one triangle and then multiply that by 12. So to find the area of one of those triangles, you can use the formula the area is equal to 1/2 b times c times sine of a. We know that the radius for this is 16. So both of those sides are 16, and this central angle measure is 30. So you can substitute those in. You'll get 1/2 16 times 16 times sine of 30. And you will get that that is 64 centimeters squared. That's the area of one. You then must multiply that by 12. That's the area of a triangle. So the area of the dodecagon is equal to 768 centimeters squared. And as I said before, there may be some variation in those answers, but that's due to rounding. As long as you show me your work, there won't be any problem. I won't take any points off as long as I can understand how you calculated your answer. But either of those methods will be fine. The next problem asks you to find the area of the triangle. So again, I'm going to look at that formula. The area is equal to 1/2 B times C times sine of angle A. So 1/2, and it doesn't matter if you call 210 B or if you call 185 B. They're multiplied, and multiplication is commutative, so that will not change your answer. So we just substitute the values in we have, the two side lengths, and sine of that included angle. And we get that the area of this triangle would be 18,576.2 feet squared. And I'm going to ask you to round your answers to the nearest tenth. Number 3 says find the length of the apothem of an octagon with an area of 144 inches and a perimeter of 48. So again, I'm going to the formula. The area is equal to 1/2 the apothem times the perimeter, and I will substitute in the information I have. I have that the area is 144 inches squared, and that's equal to 1/2 the apothem times the perimeter, which is 48. If you want to make this simpler to look at, you can go ahead and take half of 48, which is 24, and then take 144 divided by 24, and you'll get that the apothem is equal to 6. Again, you should know the formulas and be able to substitute in the information you're given to find the information that I'm asking for. Number 4 says find the length of the adjacent side of a triangle with an area of 460 feet squared, a side length of 25 feet, and an included angle of 67 degrees. Remember, these have to be adjacent sides. So one side is 25, the included angle is 67 degrees. I'm looking for the length of this side, and the area is equal to 460. So put your formula down. Area is equal to 1/2 B times C, B times C times sine of A. And then make the substitutions. You know the area, it's 460 feet squared. 1/2 B, 25, C is X, and then sine of 67. To make this easier to look at, go ahead and multiply 1/2 times 25 times sine of 67. And that will give you 460 is equal to 11.5 x. Take 460 divided by 11.5, and you should get that x is equal to 40. So the length of that adjacent side is 40. Number 5 says the areas of similar pentagons are 98 feet squared and 288 feet squared. What is their similarity ratio? So remember, if you're talking about areas, then you have that A squared over B squared is equal to 98 over 288. You are looking for A over B. Now, you can either take the square root of both sides, or you can look at those numbers and see if you can simplify them before you take the square root. And I recognize that they're both divisible by 2, so I'm going to divide both of those by 2, and I'll get 49 over 144. And then I'm going to take the square root of each of these terms, and that will give me that A over B is equal to 7 over 12, and that would be the similarity ratio. Okay. Number 6, the similarity ratio of two triangles is 4 to 5. The area of the smaller, okay, there's that word area, that tells me I immediately am going to put those squared terms there. The area of the smaller is 320, and I would like the area of the larger triangle. So I have 16 over 25 is equal to 320 over A. So 16A is equal to 320 times 25, which is 8,000 divided by 16. So the area of the larger is 500 feet squared. Boy, I wasn't good with my squared terms. Number 7 says the area of a scale model of a shopping mall is 6,200 feet squared. The similarity ratio is 1 to 1,000. Now again, I have that word area, so I have to square my similarity ratio. 1 is the scale model, so that's 6,250 feet squared. I know those numbers are a little big. And I want to find the area of the large shopping mall, which in this case must be the Mall of America. So I take 1 squared over 1,000 squared. Cross multiply. So A is equal to 6,250,000,000. Okay? So remember, anytime you're talking about the similarity ratio and the area ratio, you take the similarity ratio and square it to get the area ratio. Number 8 asks you to find the area of a decagon with a side length of 12. So I will draw in my central angle. That's my central angle. And I will find that measure, 360 divided by 10, which is 36 degrees. The side is 12. I'll draw in that apothem right there. That will be perpendicular to the side, and it will bisect that side. So now I'm going to look at this half of that triangle. This length is 6. There's my right angle. Half of 36 is 18 degrees, and I need the apothem. I will use tangent of 18 is equal to 6 over A. The variables down low, so they switch places. A is equal to 6 divided by tangent of 18. So 6 divided by tan of 18 gives me an apothem of 18.5. So to find the area, that's equal to 1/2 the apothem, 18.5, times the perimeter, which is 10 sides times 12 inches each. So 0.5 times 18.5 times 120 will give me 1,110 inches squared. Number 9 asks you to find the area of an 18agon with an apothem of 17 meters. So again, I'm going to construct that central angle and then find that central angle measure by taking 360 divided by 18, because it has 18 sides, gives me a central angle measure of 20. Again, I construct the apothem. It's perpendicular to the side, bisects the side, and bisects that central angle measure. So I will look at half of the triangle. My apothem is 17 millimeters. My central angle measure is 20. That's divided by 2. That makes that 10. I'm going to find the side length, A, so I'll use tangent. Tangent of 10 is equal to Actually, let's call that x instead of a. I don't want you to confuse that with the apothem. X over 17. Variable's up high, so you multiply 17 times tangent of 10 equals x. So that means that the side is 2.9, or let's make that 3. X is equal to 3, so the length of the side is equal to 6. The area then is equal to 1/2 the apothem, which is 17, times the perimeter, which is the number of sides, 18, times the length of each side, which is 6. And that should give us an area of 918 millimeters squared. Number 10 asks you to find the area of an isosceles triangle with congruent legs of 15 centimeters and a vertex angle of 74 degrees. So I have an isosceles triangle. Remember, isosceles means that these congruent legs are each going to be 15 centimeters. The vertex angle is the angle in which those two sides are actually touching each other, so that's the 74-degree angle. So the area is equal to 1/2 b times c times sine of a. So I can substitute those values in. 15 times 15 times sine of 74. And I would get that the area is equal to approximately 108.1 centimeters squared. Next, number 11 asks for the area of a regular, or it says the area of a regular decagon is 448 feet squared. The apothem is 7 feet, and you need to find the length of a side. So remember, the area is equal to 1/2 the apothem times the perimeter. Substitute in the values you know. 448 is equal to 1/2 times 7 times the perimeter. And to solve this, you can first multiply both sides by 2 and get 896 is equal to 7 times the perimeter. Divide 896 by 7, you get 128 is equal to the perimeter. But you're looking for the length of a side, so you have to remember that the perimeter is equal to the number of sides times the length of each side. This is a decagon, so the perimeter is equal to 10s. So 128 is equal to 10s, so s is equal to 12.8. So the length of a side is 12.8. The last problem, number 12, find the area of a regular pentagon with a radius of 20. And this is another one of those problems where you can choose to find the area of one triangle and multiply it by 5, because you know you have 5 congruent triangles if it's a regular pentagon, or you can find the central angle measure, find the apothem, find the side length, and use the area is equal to 1/2 the apothem times the perimeter. Since I'm given the radius, I'm going to go ahead and use the area is equal to 1/2 b times c times sine of a. So I have 1/2 20 times 20 times sine of, I need that central angle measure, so I'll take 360 divided by the number of sides, and that will give me that central angle measure right there is 72 degrees. So sine of 72. So I have 0.5 times 20 times 20 times sine of 72, and that gives me 190 centimeters squared. Remember, you can also, as I said before, find that central angle measure bisect that central angle. That gives you a 36-degree angle here. You are given the radius, which is 20, and if you want the apothem, you would use the sine of 36 is equal to A over 20. And you would get that the apothem is equal to 11.8. Then you need the length of the side. Cosine of 36 is equal to, I did that backwards. I'm sorry. Let's erase that. I have those backwards. I'm trying to hurry. Okay, first we'll get the apothem is cosine, that's the adjacent, cosine of 36 is equal to A over 20. So the apothem is going to be 20 times cosine of 36. A is going to be equal to 16.2. Then sine of 36 is the opposite, x over the hypotenuse, 20. So 20 times sine of 36 is 11.8. X is equal to 11.8. So the length of a side is double that, or 23.6. So the area is equal to 1/2 the apothem, which is 16.2, times the perimeter, 23.6 times 5. So I have 1/2 of 16.2 times 23.6 times 5 is, the area is equal to 955.8, which reminds me, my first answer, I have 190. What did I forget to do? I forgot that's the area of one triangle. I have to multiply that by 5. So 190 times 5 gives me 950 centimeters. So be careful. It's easy to get in a hurry and forget that. This formula right here is going to give you the area of just one triangle. It's regular, so you have n number of congruent triangles there, and you'll have to remember to multiply by that to get the area. And that was the review worksheet for quiz 10.4, 10.5.